Hey everybody, this is Mr. McKee with Net225. Today I'm going to be going over Packet Tracer 9.3.3, which is HSRP configuration guide. All right, and first thing we want to do, I've got workspace up here for Packet Tracer. You can check it out. PCs on different LANs, 2 switches. We got redundant routers here. R1 and R3, R2 is our edge router out to the internet. All right, internet's out there, and then we have a web server. All right. So what we're going to be doing is making, if one of these routers goes down, the other one's going to come back up automatically. All right. All right. So also we want to look at our addressing table. R1, which is right here on the left-hand side, has 3 interfaces. All right. If you notice, after a while, this should stick out to you. If you guys hear that in the background, it's just my printer waking up. All right. If we see a /30, 30-sided, that's a 255.252.0 subnet mask. That's usually a router-to-router connection. So let's see, gigabit 00 on router 1. All right, and I just mouse over these. All right, we don't want to. We're assigned so many IP addresses for a network, or we institute whatever policy ourselves. But we don't want to waste any IP addresses, so we'll do a /30 from gigabit to gigabit. And remember, you have 4 possible addresses in that network for that subnet mask. You have the network address, which is .0. You have 2 host interfaces or host addresses that'll be for these 2 interfaces. All right, because we're working right in here, and then you'll have your broadcast. So in our case, it'll be 10.1.1.0 is our network. .1 and .2 would be interfaces, and then .3 would be our broadcast. All right. And then, really, matter of fact, if you look at here, this is on our network, our 0 network, 10.1.1.0 network. This is on that same network. All right. This is not on that network, but this is the first usable host address on the following subnet mask. All right. So this is pretty common to set it up like this. And if you look down to here, /30s, these are all router-to-router connections. This one, this one. And then where we're going to be assigning actually addresses to our hosts, that has a /24. Because /24, 255.255.255.0, we have a possible 256 addresses, 254 possible host addresses, because 192.168.1.0 is our network address, and .255 is our broadcast address. All right. So even though .255 is our last address, you got to remember there's actually 256 possible addresses in that subnet, because .0 is really, in binary, you can think of that as being the number 1 or the first address. All right, that's what you always got to remember. All right, so looking down through here, all the rest of these are /24s. Now this one right here, this is to a web server, the 209.165.200.226. That's out there, outside, connected to the internet. All right, and then right here, this iNet interface. That's the iNet router is present in the internet cloud, which is right over here. It cannot be accessed in this activity. All right, that's great. All right. So objectives for this packet tracer. In this packet tracer activity, you will learn how to configure hot standby router protocol, or HSRP, to provide redundant default gateway devices to hosts on LANs. After configuring HSRP, you will test the configuration to verify the hosts are able to use the redundant default gateway if the current gateway becomes unavailable. Configure an HSRP active router and configure an HSRP standby router. Alright, so background, spanning tree protocol provides loop-free redundancy between switches and LAN. However, it does not provide redundant default gateways for end-user devices within a network if a gateway router fails. First hop redundancy protocols provide redundant default gateways for end devices with no additional end-user configuration necessary. By using the FHRP, 2 or more routers can share the same virtual IP address and MAC addresses and can act as a single virtual router. Hosts on the network are configured with a shared IP address as their default gateway. In this packet tracer activity, you will configure Cisco's hot standby router protocol, which is an FHRP. I don't know why I can't say that. All right. You will configure HSRP on routers R1 and R3, which serve as the default gateways for hosts on LAN 1 right there and LAN 2 right there. When you configure HSRP, you will create a virtual gateway that uses the same default gateway address for both hosts in both LANs. If one gateway router becomes unavailable, the second router will take over using the same default gateway address that was used by the first router. Because the hosts on the LAN are configured with a IP address of the virtual gateway as the default gateway, the host will regain connectivity to remote networks after HSRP activates the remaining router. Okay, great. So redundant, you know, you're gonna have redundant switches probably, but also you're gonna have redundant routers. And you guys could think of this like you're like, well, why is that? I mean, you'll have to have a router that connects these two together, but you may have redundant edge routers. But if you think of this, say the internet is there, web servers out here. This could be your ISP's router for just you, and you know their network's redundant, you know, probably multiple times over. So you're just worrying about your internal anything you have an effect on. You want to make that redundant. So if something goes down, it automatically switches over. Sometimes people have spares, but they're not actually powered up, ready to go. But you can have them like this and not even worry about it. Now, have I seen a Cisco router go down? Not in my lab. We actually had one. The only reason we swapped it out was it had a 10100 interface. So when we upgraded to gigabit, it was throttling our speed down to like 97 megs. So we had to upgrade it then. But the median time between failures is like, it averages out like 17 years, like 100,000 hours roughly. So, but yeah, that can happen. And especially if power goes down on one, you want those to have separate power supplies. They might have separate UPSs on them. So if those go down, that would happen a lot more often than an actual machine going down for some kind of technical issue. All right, so let's get started on this thing. All right, so verified connectivity. Trace the path to the web server from PCA. Go to the desktop of PCA. All right, and trace the path from PCA to the web server by executing a trace route under command prompt. So trace RT 209.165.200.226. All right, so we're starting here. The first hop, 10.1.10.112. 10.1.1.2, that first hop's there. So it's going from here, first hop is hitting here, which is gigabit 00, right there. All right. And the next hop was actually this iNet router. but they're just kind of like it's integrated into the cloud somewhere. They're not really telling us exactly where that is on in the internet, but it hops there next, and finally it goes over to your destination, which is right there. All right, now what we got here. Repeat the process in step 1 for PCB. Or, sorry, trace route to 209.165.200.226. And what you want to see is this already going, is it going that way? All right, or is it going straight out? So some things might already be configured on these machines. We don't really know. That's great. All right. So 10.1.1.2, 10.1.1.2 is more likely there, but we don't know if it's what's configured yet. So it actually is going this way, because gigabit 01 on router 2, this would be the next hop if it was going the shortest distance. All right. And then finally it jumps over to the iNet router somewhere on the internet, and then finally out to the destination address. All right, so we got those covered. All right, so which devices are on the path from PCB to the web server? Well, you saw that it went from PCB to switch 3, R3, R1, up to R2. So we don't know yet. I'm not going to look at anything, but we just know it's going that way. All right, so you have to answer that question right there. All right. Observe the network behavior when R3 becomes unavailable. Select the delete tool from the packet tracer toolbar and delete the link between R3 and S3. And delete is a little, like a little triangle with an X. And let's see. Break the link right here, click on it. I know that. Disconnect is locked. Okay. Let's see what we got here. Oh, of course. R3 and S3 right there. Bang. All right, click that. You still have the delete crosshairs. If you hit escape on a PC, it gets you out of that because you don't want to delete anything else. I was clicking on that, trying to delete that. S3, R3. All right, attention to detail works great. All right, let's see. Open a command prompt on PCB. Execute trace route once again. All right, if remembering our history, if we do up arrow, it goes back to that previous trace route command. All right. So let's let it do its thing. All right. It's not doing much so far. All right, timed out, first try. So do it 4 times. And finally, 4th time. If you guys see this in packet tracer, especially, the first time you do a like a trace route, it's going to time out until it does an ARP translation. If it doesn't already know the what MAC address is related to what IP address, that's normal. And the next time you do it, you won't have that timeout the first packet, ICMP packet for like pinging. All right, so it did it 5 times. Request times out every time. So we have a broken connection. All right, we can't get it. Won't just go this way automatically. And I'm going to do Control C to break out of that. Actually, you know what? Yeah, I mean, it's not gonna, I just won't wait for it anymore. Alright, so the broken link is not working. Let's see. So what are the results from that? Well, not much. Just we know we don't have a connection. Like, click the connection icon in the lower left of the packet tracer window, locate and select the copper straight through icon. Alright, so on the workspace, click on the I'm going to call that a lightning bolt. The little Z red, automatically choose connection type icon. We're going to click the solid black line, which is copper straight through cable. We're going to, let's see, copper straight through to gigabit 02 to gigabit 02. Right. When you first hook it up, it hadn't converged yet. You can do the fast forward button. All right, so everything's good. Hopefully everything's good. All right. After the link lights on the connection are both green, test the connection by pinging the web server. All right, so go back to PCB. Let's use our up arrow again, because we don't like typing stuff in unless we can help it. All right. I hope I didn't confuse you guys. I was saying trace route, it does tries 4 packets. In trace route, this is just hops, and it'll time out after 30 hops, which I've never seen something need 30 hops, but it's in there. All right, so still got that information. Now we got to remember though, 10.112 router 2 gigabit. Whoops. Yeah, don't do that. Router 2 gigabit 0. What was it? I want to do this. All right. It's going through this interface to the second router, to the R2 router. So it's going this way. All right, let's go down here. Ping should be successful. All right, so I didn't actually ping it. I did a trace route. All right, if we can, we'll just up arrow, then go back to trace route, change that to ping. All right. Request times out the first time, which is normal. Second time, all right. It hit it the third time. All right, so now ping it again. We'll get everything's good. All right. All right, so where are we at? All right, after the link lights, so we've done that. We're good. All right, configure HSRP on gigabit 01 LAN of R1. R1's right there. All right. Got a lot of log messages. You can look through those, but you know you have OSPF running. Certain things are up. All right, I'm gonna hit enter to get to the command line. Do enable. Enable configure terminal. All right, so interface gigabit 01 or an R1. Just make sure you're an R1. All right. Interface gigabit 01. All right. Specify the HSRP protocol version number. The most recent version is version 2. Note standby version 1 is only supports IP version 4 addressing. Okay, that's cool. All right, so we're going to do standby version And if you do version question mark, oh, you know what? I gotta spell it right. Stand by. Stand by. There we go. Version question mark. All right, 1 or 2. We want to do 2. All right, so that's set. All right, configure the IP address of the virtual default gateway. This address must be configured on any host that requires the services of the default gateway. It replaces the physical interface address of the router that has been previously configured on the hosts. All right, so we got to do standby 1 IP 192.168.1.254. All right, HSRP state change group 1 state initialized. All right, designate the active router for the HSRP group. It is the router that is used at default as the gateway device unless it fails or the path to it becomes inactive or unusable. Specify the priority of the router interface. The default value is 100. A higher value will determine which router is the active router. If the priorities of the routers in the HSRP group are the same, then the router with the highest configured IP address will become the active router. All right, that is pretty cool. All right, so the highest IP address wins. So it'll take charge basically, higher priority. All right, but in our case, we're going to do standby 1 priority 150. So that's going to be our active router. All right. If it is desirable that the active router resume the role when it becomes available again, configure it to preempt the service of the standby router. The active router will take over the gateway role when it becomes operational again, or operable again. All right, so if this one goes down, it comes back on, it takes ownership once again of the default gateway traffic. All right, so standby 1 preempt. All right. So that's our main router. All right, R1 between these two pairs. All right. All right, so answer this question. What will the HSRP priority of R3 be when it is added to the HSRP group 1? All right. So think default value. I won't even tell you, but we're gonna check that out though. We'll put a star on that and come back to it. So configure HSRP on route. Configure router 3 as a standby router. Configure the R3 interface that is connected to LAN 2. Repeat only steps 1B and 1C above. All right. So, all right. So we're gonna go to router 3. And it kind of tells you enable configure. Whoops, I need more coffee today. Configure terminal. All right, standby version 2. Yep, standby. You gotta spell it right. Standby version 2. Oh, I'm sorry. So we need to only do, where did it say? B and C. Interface. I do our interface. Alright, so let's look at this. Alright, so on router 1 that was gigabit 01, we're going to do gigabit 00. Let's see. So when you do interface gigabit 00. Alright, now it'll work. Standby version 2. Alright, standby. Standby 1 IP 192.168.1.254. Alright, group 1. Looks like it's working. Alright. So we did step 2. So far so good. We're at 68% completion rate. Alright. So verify HSRP configuration. Verify HSRP by issuing the show standby command on R1 and R3. So verify the values of HSRP role, group, virtual IP address of the gateway, preemption, and priority. Note that HSRP also identifies the active and standby router IP interfaces for the group. So let's do 1, 2, 3, like so. Go in here on router 1, let's end it. Alright, let's do show standby. Alright, gigabit 01 is on group 1, version number is 2, state is active, virtual IP address is the default gateway. Let's do end on R3. Let's do show standby. Alright, right now gigabit 00 on R3 state is standby, so it's in standby mode. Alright, HSRP also identifies the active and standby router. Alright. Standby router is that one. To tell you the active router is this one, which is actually over here. 192.168.1. Alright, stay up there. One 68.1.1. So that'll be router 1. Alright, there's 1.1. 192.168.1.1. It's telling you from here on router 3, it's telling you, okay, my active router is that one. Alright, but I'm in standby mode. It's telling you I'm the active router, but my standby router is 192.168.1.3, which is gigabit 00 on R3. So take this path. If that path can't work, goes down, whatever, go to this path. All right. Let's see what we got here. Show standby, show standby. We should see the same stuff on here. All right. What router is the active router? What is the MAC address of the virtual IP address? Let's see if it shows it. All right, so looking at here, there's our MAC address, and also here's our MAC address. That's the same. Yep. All right. So that's fine. All right. All right, what is the IP address and priority of the standby router? You should be able to look in standby router and be able to tell that. All right, use the show standby brief command on R1 and R3 to view an HSRP standby summary. Sample output is shown below. Show standby brief. All right. P indicates configured to preempt. All right. So preempt, this loses connection, it's going to go to the standby. As soon as it's powered back up or connected back up, it's going to take over priority once more. And let's look at R3, which should be different. Show standby. All right. If you see right here, this is the active, so it says local for the active. All right. On R3, you have, all right, you have this in standby. All right. Notice priorities: standby priority, the active priority. All right. Standby is local, so you know standby local. This is the standby router. All right, that should make sense. This is your fault gateway on both. .254 interface. All right, our IP address. So let's see. Use the show standby brief command on R1 and R3 to view the HSRP status summary. Sample below. Change the default gateway address for PCA. All right, so we need to go up here. Let's do these in order. PCA, default gateway, 1.254. Let's do S1 now, just so I don't miss any. All right, enable figure key. Default gateway 192.168.1.254. All right, that one's done. And actually, we can copy this. Copy S3. Hit enter. Enable. Configure terminal. All right, we can paste it. That one's good. And finally, PCB. Go to IP configuration, go to default gateway, change that 1 to a .254. All right, so now we're at 100% completion rate, so everything should be good. All right. Verify new settings, issue the ping command from both PCA, PC. Actually, that should be PC. That should be PCB. All right. I'm going to do up arrow to get my history, but I'm going to take out trace root and type in ping. All right. It's good. PCB. All right, I'm using my up arrow again. That one's already set to ping. So my pings do work. Are the pings successful? Well, you guys should have been able to see that. All right, make the active router become unavailable. Open command prompt on PCB. Does the path differ from the path used before? All right, it's not telling us to make it do that right now, but open a command prompt on PCB. I'll make this a little bit bigger. Really, come on. Drag down here. All right. Trace route. Does the path differ from the path? Yep. Okay. All right, so that should not be this. Should not be different. All right, I want to make sure though. I was checking these IP addresses. At first, we went from PCB, we went to S3, R3, then up to R2, which is right here. I might have said that incorrectly. See, currently we're going through 192.168 1.1, which is R1. All right, but originally, I might have said that incorrectly. Here's our first trace route. Trace route 192.168 1.3 is R3. All right, it was originally going this way and then up, not this way. All right, but now it's going that way. It's actually going straight over and up because R3 is not the active HSRP router. All right, so now it's going there. All right, interface 192.168 1.1 is router 1's gigabit 01, which is right there. All right, let me make sure I didn't say that wrong somewhere else. Okay, PCA would do, okay, router A originally went that way, router B went this way. Okay, now it's changing because now R1 is the active router. And we can see right there, that's R1, this is R2. This is the iNet router interface, and finally out to the web server. All right, so we are down. Done all that. Done that. Done standby. Okay. So does this path differ from the path used before HSRP was configured? Yes, because now it's going through router 1 instead of router 3. Which hopefully I said that correctly. Alright, so let's see. Okay, we've answered that. We're going to break the link to R1. Select the delete tool from Packet Tracer toolbar and delete the cable that connects R1 to S1. Alright, so delete tool, R1 to S1, click on it, click escape. Alright, now we have router 3 to router 2 only. Alright. Immediately return to PCB and execute the same command. Alright, you see it. It might take a minute, but it immediately went. Let's watch it. Alright, the first time it did timeout, it didn't show us what it was, what interface it was, or IP address. Now what we see is it changed over to our really all right, now it's 1.3, which is router 3. That interface right there. All right, how is this trace different from the previous trace? You can answer that. HSRP undergoes a process to determine which router should take over when the active router becomes unavailable. This process takes time. Once the process is complete, the R3 standby router becomes active and is used as the default gateway for hosts LAN 1 and LAN 2. All right, reconnect R1 to S1 with a copper straight-through cable. And S1. All right. Let's converge that. Fast forward button. All right. Execute a trace from PCB to the web server. You may need to repeat the trace to see the full path. That's what we needed to do last time also. All right. So let's do this again. Let's see if it changes. We're going to get a couple of timeouts. Well, no, we didn't. We let it sit. That was why. All right. But now it's going through 192.168.1.1 again as the default gateway. And the actual default gateway is .254. All right. So what path is used to reach the web server? There's the path. And if the preempt command was not configured on the HSRP group on R1, would the results be the same? Well, they really shouldn't be, because it's not going to go, it's going to use this router. It's not going to use automatically go back to that R3 router. It'll stay on R1. All right. Or I'm sorry, R3. How did I say that? It'll go past R3 to R1. Because what it does, if you don't save preempt back to the active router, it's just going to stay on the default router. Even when the other one comes up, that one will become the like the backup router. All right, but that's it. All you need to submit is copy this. Well, actually, copy the packet tracer file, the completion rate, and a copy of the questions. All right, I will send you out a document with those questions on there. It'll be a Word document. It looks like just like this. All right. Well, thanks for watching.